Hi, strays. I don't know who you are. Hmm. Really? Because I had people doing a different class this morning that said that they can type. They typed without making an account. Um. What if you just tell me your name? Oh, hi, David. One. No, I meant two. How do you forget if you're David one or David two? And who are you as Snagira? Oh man, it's like playing a guessing game with your usernames. Let's see. So I have David two, and let me see. All right. S Najira. Who do I have? What's that name? All right. Snajira, I don't know exactly who you are. If you could just tell me your name, I would appreciate that so I know who you are. And Christopher Abrio, I don't actually know who you are. But yes, on worksheet four, you would just have to take a picture of one open ended problem and submit it to Google Classroom just so I have proof that you guys did something today. Once again, even though I would like you guys to do worksheet four, because when we come back, we're going to have a test. Yes, in terms of getting credit for today, please just take a picture of at least one problem on worksheet four and upload it to Google Classroom. Just one question. I would encourage you to do more. Just at least take a picture of one question. And I would love to know who Julio Sucks is. I don't know if I have a Julio in class. Checking people. Take a picture on your phone. You can take a picture on your phone, and then if you have the classroom app, you can upload it using the app. Or if you have your phone, you can email it to yourself on your school account, and then you can hop on the computer, your Chromebook, and upload it like that. If you're really talented, you could take your Chromebook and access the camera up top and take a picture of it from there. Julio, don't worry. I already took a screenshot, and when I figure out who you are, you're going to get written up. David, too, which problem are you referring to? I'm looking it up for you. Yes, because at this point in time, the bullet is stuck in the piece of wood. So so the two masses would move together at the velocity you find in question A. The fact that it's inelastic means the two things are stuck together. So yes, the mass would be in this case 2.001, and the velocity will be whatever you get for A. David, too, does that answer your question? That's okay, David. All right. All right. Colin, you mean number 4 on the multiple choice, correct? Number 5 on the multiple choice? Okay. So don't forget, an explosion is a type of collision, so momentum is conserved. So what that means is the momentums are going to come together to equal the total. The total before anything happens is 0 because the cannon is just sitting there. After the explosion, the cannonball goes to the right with 5,000 kilogram meters per second. So to cancel that out to get 0, the answer would have to be B. It would go to the left 5,000 kilogram meters per second. So that once again, it cancels out to get 0. Is that okay? Yep. No problem. So yeah, you have the exact right idea. In 6 and 7, they do bounce off of each other. So with that being said, A is the thing moving before they collide. 7 I'm sorry, A is the thing moving, B is the thing that's stationary. So when they collide, they exchange velocities. So B would then be the one moving, A would be the one that's now standing still. So the answer for 6 is going to be 0, and the answer for 7 is going to be B. So 6A, 7B, because they're just exchanging velocities. Okay. So, here, quick question. David, two, there's an assignment on Google Classroom where I actually posted the copy of the worksheet. You could just post your picture in there. Christopher, once again, I wish I knew who you were. For Christopher, were you in the classroom on Tuesday or Wednesday when I wrote down on the board what equations we were going to use for what problems? Okay. Hi, Anthony. So let me just write this down. So with these problems, for A, you're either going to use, depending on if you like the table method or the equation method. I'm writing it down and I'm going to show you guys. Or the opposite. I mean, either way you go, you're going to start with. Is that good? You're going to start with one of those two equations. It just depends on if it's an explosion or an inelastic collision. The top one is for the top one's for an explosion where things separate, and the bottom one is for inelastic where they come together. So you, as a smart teenagers, I know you guys are, you have to figure out which one is which. And then after that, for B and C on them, there's going to be broken down into two categories. And I'm just writing them down for you guys. Hi, universe. David from period 4. Okay, David from period 4 and Davian are here. Okay. Guys, I'll get to your questions in a second. I'm just going to answer Anthony's question first, where I'm giving you guys the equations. All right. And v squared. Okay. So once again, I apologize for my handwriting, but once again, the top two equations, those are for explosions or inelastic collisions. That's how you're going to start the problem. And once again, you as a smart kid can figure out which is the example here. Are things separating or are they coming together? From there, we can do energy-based problems, and they're going to start with kinetic energy being 1/2 mv squared. And then from there, we're either going to go to spring energy or height energy. So B will be asking about kinetic energy, and then you need to decide, are you going to go to GPE or EPE from there? For example, problem 10, for question C, it talks about the height. So question C, we're going to use the GPE equation. After that, for the other side of it, we're going to use the kinematic equations, the ones that we did in the beginning of the year. An example of those guys would be something like 14, and I apologize for the formatting. 14, they're saying there comes to a stop in 16 meters. What is the acceleration? So obviously the acceleration, you're going to have to find one of these depending on what you know. I'll give you a hint. The velocity is going to be 0 because you're coming to a stop. And yeah, those are the questions you're going to use for B and C. So once again, if they talk about acceleration, you're going to use one of these guys. If they're talking about something like height or a spring or something like that, you're going to use one of these ones. And I hope that clarifies, Anthony, about what equations you're going to use for those. Our number 10 and 11, yes. So Davian, for 10 and 11, those are examples of where you guys start with the chart and find the velocity from there. And then we're going to use some of the old equations, the ones I just had up on this piece of paper. If you guys want to pause your screen and write those down, you can. But these are the equations, the main ones that we will give you on the test. Obviously, you will have the basic P equals mv, the impulse one, things like that. But in terms of the open-ended, these are the things that you need. And yes, you're going to start off the problems with either the chart method or the equation, if you know what that is. So what you need to do is finish page 4 and send a picture. Yeah, you don't even need to finish page 4. Just send a picture of a problem. Just send a picture. You could do the entire page if you want to, but just submit a problem, a picture of a problem, so that I can see that it's your handwriting, that you guys are actually doing it. Can I make a doc and put the picture? Yeah, of course. I don't care what format you do as long as you guys actually post a picture of it. Yeah, sure. It could be in any format. Yes, the two masses do combine. The bullet is getting stuck in the bullet is getting stuck in the piece of wood, so the two masses are going to move together. Yes. So for the rest of the calculations, you're going to use a mass of 2.001 for the rest of the problems because the bullet will be stuck in the piece of wood. Page, stop. Page. No. No. Hey, stop. Wouldn't V1 for 0? Um, it depends. Are you considering M1 to be the brick or M1 to be the bullet? Um, if you're considering it to be the brick, then yes, it would be 0. If it's the bullet, it will not be 0. It will be 15. So it depends on which one you're considering M1. So how do I do 8 and 9? Eight and 9 are straight from your note packet. I mentioned kinetic energy. Remember, elastically, things bounce off perfectly. So if things are bouncing off perfectly, that means that the energy is going to be the same because there's no loss of energy when they're bouncing. I got A and B, but I would want to make sure those are right. Yes, the answer for 8 is A. But then for, hey, Peters, you want to say hi to everyone? Hi. Ooh, careful there. You want to say hi? Let's say hi. Oh, I know. I know. Yes, 8 would be A. Inelastic collisions, things are getting stuck together. So the kinetic energy is not conserved because essentially those two things are bringing each other to a stop. So yes, 8 is A, 9 would be B. Correct. Thank you. It's been a real struggle staying here all day with her. I'm telling you that much. Well, David, I know for a fact Monday we're going to do something like this as well. And then Monday afternoon, we're going to get a call from Dr. Zykowski and talk about the rest of the week or the rest of the month. I don't know. I know as much as you guys do at this point in time. All I know is that we're going to do this again on Monday. So your guess is as good as mine. Hi, Drippy or Two Drippy. I would love to know who you are. Um, I only know Monday. And we're not canceling school, we're remote learning. There's a big difference. Canceling school means we're going to have to come in during one of our days like spring break or something like that. Remote learning, we're not canceling school, we're just learning remotely. So there is a big difference between school getting canceled and remote learning. Oof. Oh, hi, Aiden. Yeah, so I don't know what the deal is for. All I know is that Monday we're going to do something like this too. I'll be here. Same idea, field questions you guys have. Um, and you guys know just as much as I do when we get the calls from Dr. Z. Colin, what number are you getting for 10A, the first question? Yeah, what are you getting for the velocity? I see, Colin. I'm just double checking my numbers. Just got to get on my calculator. Page. The dog's freaking out with a ladybug. Up, and the ladybug's dead. Page. Page. Oh yeah, that calculator is now going to be dog poop, or that ladybug is now going to be dog poop. Let's see. Oh, I'm just pulling it up. Colin, I got the same answer. You are doing it correctly. In this case, the bullet wasn't going very fast, so the wood is barely moving at all. That is going to make your answer for the next two questions also really small. You're going to get really small decimals for those. Cheers. Cool. Page. Bye bye, Colin. Have a good weekend. No, you're going to be using the combined mass and the new velocity from A, because at those point the two things are stuck together. So if you're referring to number 10, the mass will be 2.001, and the velocity should be what Colin got before in the comments, 0.019 meters per second. Those are going to be the values you use. That's fine. All right, folks. It's been about 50 minutes or so. Um, we're going to call it a day. Thank you for you folks who asked any questions. This video will be available on Google Classroom so you guys can look at it over the weekend. Yeah, David, I know what you mean. Um, so we are going to, as I said, just call it a day. Keep an eye on Google Classroom. Um, Yeah, keep an eye on Google Classroom, and we'll do this again on Monday. David, you get the last question. I would prefer that you put it on the actual assignment on Google Classroom. So there was on the assignment page or the classwork page, there's the actual worksheet for assignment. And if you can just submit your picture there. Once again, it could be a picture using Google Docs or something like that, or from your phone. But any way you do it is perfectly fine with me. And guys, have a good weekend, and we'll see you next time.